all the way from the heart of Asia, simply saying the art of teaching is the art of learning. What we're going to tackle today will just serve as a recap of what I've tackled before on my past videos. But first of all, guys, wherever part of the planet you are, may you all be blessed and safe under the wings of the holy angels. So now our topic is all about finding the nth term and the sum of terms in a sequence. Okay, again, this belongs to geometric and arithmetic series. Maybe you're gonna ask me, why am I always talking about geometry? It's because it's our main topic again. Again, on my tutorial class. But shout out to those teachers who are telling me I'm doing the spoon feeding process to the students. No, I'm not. I'm not. To make it clear, I'm just giving them examples and illustrating them the process for them to easily understand the problem and let them solve it on their own. Clear? Back to our main topic. As what I still remember, geometric is useful for economists in describing income distributions, and for biologists in calculating data points and describing the sizes of bacterial populations. Same with arithmetic, which is useful for statisticians, yes, in representing average temperatures. If we say finding the nth term, then it's geometry, cause it's all about the missing nth term of a sequence. But if we're looking for the sum of terms in a sequence, then it's arithmetic. Again, geometry is finding the nth term in a sequence, and finding the sum of terms in a sequence is arithmetic. Clear? So, let's go, guys! For example, we have here, find the 8th term in the sequence 4, 12, 36, and so on. It's geometric, right? So here's our formula. An is equals to A1 times R raised to n minus 1. Now, first, what are the given terms? We have A1, which is 4, which refers to the first number, and R, which is 3. This is what we called our common ratio or our constant R, and n, which is 8, and that is the term we're looking for. Now, where did the constant ratio 3 came from? From our sequence 4, 12, 36, and so on, what will you multiply to 4 and the product is the second number? 3, right? Same with 12 times 3 is the third number, and so on. Meaning our constant R is 3. So now here's our solution. Following our formula, An is equals to A1 times R raised to n minus 1. And what is our given n, which is 8, equals to what is our given A1, we have 4, right? Our first number, times R, our constant ratio, which is 3, raised to, what is our N? 8, that is the term we're looking for, minus 1. Then follow A8 is equals to 4 times 3 raised to 8 minus 1 is 7. And then A8 is equals to 4 times, what is 3 raised to 7? You can easily find it if you're going to use your calculator. So, 3 raised to 7 is 2,187. And then, A8 is equals to 4 times 2,187. We got 8,748. Meaning, it's the 8th term of the sequence given. Another example. What is the 6th term of the sequence 3, 6, 12, 24, and so on? Again, from our formula, An is equals to A1 times R raised to N minus 1. We have the given A1 is equals to 3, which is the first number, and R, which is 2, our common ratio, and N, which is 6, the term we're looking for. Now for our solution, following the formula again, An is equals to A1 times R raised to N minus 1. What is our N? 6 is equals to, what is the given A1? 3 times our common ratio, which is 2, raised to N, which is 6, minus 1. Then follow, A6 is equals to 3 times 2 raised to 6 minus 1 is 5. So, A6 is equals to 3 times 2 raised to 5. What is 2 raised to 5? Using the calculator, you can easily find it. So, we have 32. So, A6 is equals to 3 times 32, 64. Meaning, the 6th term of our sequence, 3, 6, 12, 24, and so on, is 64. Now is for the sum of terms, which is the arithmetic sequence. For example, number 1, find the sum of the first 10 terms of the sequence 10, 20, 30, and up to 100. Take note, how would we know if the sequence is either arithmetic or not? If the difference between every two adjacent numbers are the same, then it's arithmetic. But if it's not constant, then it's not arithmetic. Just like from our example, 10, 20, 30, up to 100, look, 20 minus 10 is equals to the first number, and 30 minus 10 is the second number, and so on. So here we have constant 10. But if, for example, we have 10, 12, 13, 16, 17, and so on, if you've noticed, from 12 minus 2 is equals to 10, the first number, then 13 minus 1 is 12, the second number, 16 minus 3 is 13, the third number, and 17 minus 1 is equals to 16, the fourth number. See guys, it doesn't have constant difference. Now back to our problem sequence. 10, 20, 30, up to 100. We're looking for the first 10 terms. We have here our formula. Sn is equals to n divided by 2 times a1 plus an. But remember guys, this formula is only used if the last term is given. And we have our last term, 100. Again, what are the given? A1 is equals to 10, which is the first number, and an is 100. This is the last number given, and n, which is 10, And this is the number of terms we're looking for. So for our solution, following the formula, Sn is equals to n divided by 2 times a1 plus an. And what is our n? 10. So we have S10 is equals to 10 divided by 2 times our a1, which is 10, plus our an, which is 100. Then S10 is equals to 10 divided by 2 is 5 times 10 plus 100 is 110. So we have our answer. S10 is equals to 550. Therefore, the sum of the 10 terms from 10 to 100 is 550. So that's it, guys. Once again, it's Dhaizy Bhonz, always saying the art of teaching is the art of learning. If you have some concern to ask or suggest, just let me know. You're free to comment down below. Much love. God bless.